evaluate the integral using the given change of variables. So we have double integral over the region R, where R is the region bounded by the ellipse here, and this ellipse is given, but if you don't know how to graph this, we really don't need this. Okay, but this is the region where we are integrating on using these change of variables. X equals this, x equals, and y equals this. So the whole idea here is this region is not that easy to integrate with. If you want to integrate this function, the function is not bad, but the region is not that easy. We can divide into 4 different parts and we can integrate, but if we make this substitution, change of variables, this region might change into much better one. Let's see. Okay, so we have this x squared minus xy plus y squared equals 2, and let's plug in these substitutions. X squared minus xy plus y squared over 2. X is root 2u minus root 2 over 3v quantity squared minus root 2u minus root 2 over 3v times root 2u plus root 2 over 3v plus y squared, that is root 2u plus root 2 over 3v quantity squared equals 2. Now we need to multiply this by itself, multiply these two, and multiply this by itself. If we multiply this with itself, we get this, minus, multiply these two, middle two terms cancel, and we need to distribute negative sign, so we get this, these two terms by the way, and finally this quantity square is, we got 1, 2, and 3 terms equals 2. And now this one and same thing, cancel, negative positive, and 2u square minus 2u square also cancel. So the left hand side is pretty much, what is left now? 2u squared, 2/3 v squared, 2/3 v squared, and 1 copy of 2/3 v squared. So 6/3 v squared, that's 2v squared equals 2. And we can divide both sides by 2, so we get u squared plus v squared equals 1. So we get, just transform this ellipse to a nice curve, and as we know, this is the standard circle with radius 1. Standard means center at 0, 0. So our new surface is just a circle, okay, in UV plane with radius 1. So instead of integrating on this ellipse, we are integrating on this circle. Okay, now let's go back and write this in terms of UV. Now we need to compare the areas of these two regions for we find the Jacobian, that's x, y are being converted to UV. So we need to compute this, which is x in terms of u, y u, y v. And if we go up, look at here, x is this, y is something but plus. So find parcel of x with respect to u, we get 2 root 2, just root 2, and x with respect to v, negative root 2 over 3, yu root 2, positive now root 2 over 3. It's absolute value, multiply root 2 on the top, we can write 2 over root 3 minus, and here is negative, so plus 2 over root 3. So this is 4 over root 3. Okay. Now the given integral that's on ellipse, and we had x square minus xy plus y square dA will be same as new region. Let's say this is D, which is a circle, and we need to convert this into UV. And if you look at closely, this left hand side is same as the integrand, okay? And this one with UV we have here, okay, 2u square plus 2v square. So 2u square plus 2v square times absolute value of the Jacobian, which is 4 over root 3 dA. That's in this area. This is same as we can pull 4 over root 3 out. Inside we can factor 2 out. That's 4 times 2, 8. And we have this region D, which is a circle. U square plus V square dA. This is like x square plus y square. And in a circle, we know that x square plus y square in terms of polar coordinates, that's r square. Okay, recall x square plus y square is just r square. And here r goes from 0 to 1. Okay, and angle goes from 0 to 2 pi. So this double integral can be written as, and dA will be r dr d theta. This is r square. And r from 0 to 1, theta is outside, theta from 0 to 2 pi. Let's evaluate this. 8 over root 3, 0 to 2 pi, we have r cubed, and antiderivative is r4 over 4 from 0 to 1. 8 over root 3. Now let's evaluate this. Upper limit 1 raised to 4, 1/4 minus 0, just 1/4, and we can pull that outside. Okay, there is nothing left, means 1. Antiderivative of 1, once we take this out, there is 1 left, and antiderivative of 1 is just theta with respect to theta, and 0 to 2 pi. 4 goes 8 twice, so 2 root 3 times, now theta equals upper limit minus theta equals 0, that's just 2 pi. And finally that's 4 pi over root 3 final.